Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I speak to Dr. ARIF. Today we are from Group 1. We would like to present to you Experiment 1 Marcet boiler. Okay, first thing first, I would like to introduce to you our group member. My name is Emilia Rosina and my other members are Aliana Suha, Izzatun Najla and Nur Farisha Udina. Let me continue to the introduction part. First, as we know, water molecules could escape from the surface when there is presence of energy. The water will reach the equilibrium state at the boiling point. The water surface pressure determines the equilibrium state because the lesser the energy, the easier the molecule will escape to the surrounding. In this experiment, we are using Marcet boiler to determine and investigate the relationship between pressure and temperature of saturated steam. The experiment slope, which is delta T over delta P, is obtained from the water at saturated temperature. The theoretical part of the experiment is we use to determine thermodynamic properties of a pure substance. The important is to obtain data characteristic using experiment formulas and particular technique. As you know, temperature and pressure is one of the easiest part in thermodynamic properties that can be measured. In this experiment, we are using Clapeyron equation 1. The derivation of this formula is we are using delta T over delta P in saturated. It is equal to temperature that multiplied by the volume of the steam minus the volume of the water over the enthalpy of the water minus the enthalpy of the steam.
This is our experimental setup for Marcet boiler experiment. As you can see, we already label all 10 parts of Marcet boiler experimental setup. The first one is heater switch, the second one is master switch, the third one is manometer, where we can see the increment and decrement of the pressure. The fourth one is temperature gauge, where we can record the temperature for each increment and decrement. And then next, temperature sensor, and there is filler plug, safety valve, overflow valve, boiler with insulating jacket, and the last one is drain valve.
The next one is methodology. Firstly, we need to open the filler plug with spanner. Then we open the overflow valve. When both of them are open, we fill the water into the boiler until the water overflow from the boiler. The next step is close the filler plug and tighten it. Switch on the main switch and heater. Close the overflow valve when the temperature reaches 97 degrees Celsius. Then we record the temperature for each increment of the pressure from 0.5 bar to 5.0 bar. Then we close the main switch and heater and we record the temperature of each decrement pressure 5.0 bar to 0.5 bar.
This is the result. The tabulation of data starts with gauge pressure from 0.5 bar until 5 bar, absolute pressure from 1.5 bar until 6 bar, increasing pressure, decreasing pressure that recorded from the experiment, mean, measured slope, and the last is calculated slope. At the below, we can see that there's a calculation of calculated slope. The formula is TBG, which is the T is temperature in Kelvin unit, Bg, volume of steam, divided by HFG, heat transfer of vaporization, or the short form is HT minus HF. We take the value for 1.5 bar row, then we substitute the value from the row, and we got the answer in Kelvin per kilopascal. Next part is calculation. The first is calculation of TP. To find the TP at 2.0 bar of absolute pressure, the formula is pressure at 2.0 bar will be minus with pressure at 1.5 bar. Substitute the value from the table and we got the answer in kilopascal. For the calculation of dt at 2.0 bar, the formula is temperature at 2.0 bar minus with temperature at 1.5 bar. The answer will be taken in Kelvin unit. So make sure to add 273 to each temperature before we subtract it. So for the calculation of measured slope, the formula is dt over dp. Let's say we take the value of dt over dp from the 2.0 bar row. So substitute the value, the final answer will be taken in Kelvin per kilopascal unit. The addition of table with percentage error column. So to calculate the percentage error, the formula is measured slope minus with calculated slope divided by measured slope and then times with 100%. Let's say we want to get the percentage error for 2.0 bar in the absolute pressure. We put the value on the row and times with 100% and then we will get the percentage error. This is the graph that we got from the heating process. This graph shows that absolute pressure and temperature are directly proportional to each other. The temperature increases, so the pressure will also increase. The next graph is for the cooling process. We still got the same as title from the previous graph, which is absolute pressure and also temperature. At first, the temperature still increased after the heater was switched off. But observing throughout the graph, the temperature will decrease when the pressure decreases. This is the graph of measured and calculated slope versus absolute pressure. As you can see, the curves plotted are slightly different to each other. The measured slope one is not really smooth compared to the calculated slope. This is due to the error occurred during the experiment was conducted. For the discussion part, the aim of this experiment is to determine the relationship between pressure and temperature. Before experiment is carried out, the reading of temperature of water is at room temperature, while the pressure is at 0. From the curves formed in graph 1 and 2, they are quite similar to each other. As the experiment was conducted, we saw that the temperature increased when the pressure increased. After the heater was switched off, we noticed that the temperature decreased as the pressure decreased. So, the relationship between the temperature and also the pressure are dependent to each other. This can be seen from the previous plotted graph that pressure and temperature are directly proportional to each other.
The next one is conclusion. Based on the graph, it can be seen that the relationship between pressure and temperature are directly proportional. According to ideal gas law and principle of thermodynamics, as the pressure increases, the temperature is also increases and vice versa. Based on the graph that we plotted, which is P versus T, we found out that the graph is a curve and the slopes of the graph is slightly different from the theoretical values. The difference might occur because we face several difficulties such as modest changes in temperature measurement due to possible energy losses. To increase the accuracy of future experiments, our eyes must be perpendicular to the reading of gauge pressure to avoid parallax error. Not only that, air must be completely removed from the valve by closing the overflow valve at between 97 degrees Celsius to 100 degrees Celsius to avoid any inaccuracy in readings.
There are 3 safety procedures that our group have listed on. First, make sure that all the valve at the level side tube is always closed before turning on the heater, as the side tube is not designed to withstand high temperature and high pressure. Second one, never open any valve during the heating of the heater, as the pressurized steam may cause severe injury. And the third one, do not touch the boiler during the heating, as the hot surface of the boiler may cause a serious burn. So, these are the references that our group refers to during making this report. Thank you.